do me a favor and read the first sentence of the subjective? Okay, so you've seen these two graphs before. Sinusoids of the same period, we just add them together, and it forms a sinusoid with the same period. That's what, like that musical note problem that we did with Clara and whatever the other girl's name was. Cora. That was the situation that we were looking at. The figure below shows the result of adding two sinusoids with unequal periods, which might happen if you play two musical notes on different frequencies at the same time. We'll learn about composition of ordinates. What does the word composition mean again? Essentially. Put together. Ordinates is the other word that we use for coordinates. I don't know. They use ordinates, so I use it too, just to make sure everybody.
You can't have a C and an O.
Yeah.
Let's make this a little bit more difficult.
Anyway, so composition of ordinates where sinusoids are added or multiplied. Harmonic analysis is where we reverse, and not reverse the profits.
The profits?
It should be process.
Awesome.
Okay, so composition of ordinates is where the new graph is made. Harmonic analysis is where we work backwards to figure out what two graphs made this one. Yes?
Is this what they use? There's a helicopter that uses a signal to cancel out its own noise, so that it's like virtually kind of silent.
Oh, it's destructive interference.
Yeah.
Waves.
Yeah, that would be this, basically.
Yeah, destructive.
Alright, this is a very simplified version of that. Alright, we are going to look at two examples on the next page, both of which will show us how to sketch a graph composed of two sinusoids where periods are not equal. We've actually kind of already done this with the exploration 48, which is nice. But we're going to compose new graphs here in your notes. Go ahead and go to the sample one. Alright, so the figure shows the graphs of 3 cosine theta. Hold on. Are these the same ones?
I believe they might be. Wait, what? Which one?
No, they're not.
I'm confused.
Whoever wrote these notes is not creative.
What?
Oh wait, was that the cross we wrote?
The figure shows the graph of y equals 3 cosine theta and sine 4 theta. We're supposed to sketch the graph of y equals 3 cosine theta plus sine 4 theta, then plot the function on the calculator. How well does your sketch match the actual graph? Okay, so before we do anything with the calculator, we're going to sketch the new graph by hand. And when you are adding, let's see if we can remember without looking back at our exploration, what is variable when you're adding? The sinusoidal axis or the amplitude? Should be the sinusoidal axis. Yeah. Alright. So what I would do is go from key point to key point. You're looking at the y values on both curves and adding the values of the y values together to get your new point for your new function. Yes.
So the sinusoidal axis is going to follow the cosine curve, right?
Yeah. So, 0, I'm just going to start the x-axis. 0 plus 3 would be 3. So I'm going to plot a new function point there. I'm going to go to the high point here. That high point y value is 1. 1 plus a little bit less than 3 would be what? A little bit less than 4. So I'm going to go up here a little bit. Come to this next crossing point. 0 plus about 2 would be 2. Come down to your minimum point. That's -1. -1 plus 1 would be about 0. 0 plus 0 is 0. Next high point. Notice I'm going to all the high, low points and the x-intercepts. Those are your key things to look at. So this high point's about at 1. The y value is 1 plus what? About a -1?
Yeah.
0. It's not going to be, our sketch is not going to be perfect, but it should match very closely. 0 plus, where am I? -2 would be -2-ish. low point, -1 to -3 would be -4. I'm going to let you finish out the rest of that.
I sense sarcasm.
Good, because I'm laying it out for you. It's overpowering.
That's fine. It's so nice to tell you this is but we figured out something very awesome. Actually, we figured out something
And if someone thinks they have it, raise your hand and see if you can look.
Eureka!
Oh my.
Unnecessary. Unnecessary.
Do you want to get cake
Oh,
from
I've
Kenny?
got some for you. Here.
Sauerkraut?
I have it.
It's close.
Okay.
Why is it Eureka? Totally necessary.
Alright. I don't know if you can see Connor's here.
Mine's gonna be more visible.
Mine's better than that.
Donnie's looks really similar.
So does mine.
Okay. Now our sketch is not going to be perfect because we're just kind of eyeballing the y values. So they're not going to be exactly the y values that we should plot. But you can kind of see that we do have a variable sinusoidal axis now. And this function, which was a sine function, is now following the cosine function. Okay.
You could probably split it.
That looks like a heart on the
Kind of does, yeah.
Well, this is what somebody's heart beat looks like.
Alright.
Actually, no.
So if you are doing this by hand, which there is one question on the test, because it's part of your standard, is that you're able to sketch it by hand, then what I usually do is encourage you to look for high points, low points, and then what were the other points that we looked at? X-intercepts on the two graphs. At each theta value, you choose estimate the y coordinate or ordinate, if you want to write that. Of each graph. And add them. And you plot the new point. You just kind of have to do that over and over again until you get what your function should look like. Except if you already know that if you add two sinusoids with differing periods, that you'll get a variable sinusoidal axis, you kind of know what the shape is going to look like, so it's a little bit easier.
Oh, it's gonna look weird.
Alright, I'm going to use a different color here. And actually, I'll just pass that green pen. If you want to use green pens, just to, because we're use the same graph here, and now do the multiplication of both of them to make a new graph. So you might want to use a different color just to distinguish the two. Alright. So, same figure as above. For example 2, we're going to sketch the graph of 3 cosine theta, sine 4 theta.
Can we just do it on this graph up here?
Yep, that's why I give you a different color. And check your sketch with your graphing calculator. So we're just going to do both sketches and then we'll graph them both at the same time. So when you're doing this, you're doing the same thing. You're looking for the high points, low points, and x-intercepts and multiplying the y coordinates together to get your new point. So 0 times 4. Yes?
Why is I don't understand why this is the standard. Like it seems like
So simple.
Because you have to be able to graph it by hand.
like you don't even need to know
one piece of one standard. It's not the whole
Yeah,
standard.
this is the fancy ruler.
It's just one piece of it.
I'm saying, like, you're just adding and multiplying.
Fingers crossed.
Yep.
You're gonna get the cube that's working now.
Try it, yeah. Alright, here we go. 0 times 3 would be 0. The next high point, 1 times 3-ish would be 3-ish.
Fingers crossed that was a no-go.
I'm not sure.
Oh, stuck.
Okay, 0 times anything is 0. So what can we do right off the bat at any x-intercept here? Won't it be an x-intercept for this new graph? Yeah, so I'm just going to go ahead and at every x-intercept, I'm just going to mark it. Because I know it's going to happen. And then really all I'm concerned about is the high and low points. So, low point, -1 times 1 would be -1. High point here, 1 times -1 would be -1. Low point, -1 times about -3 would be what? +3. I'll let you finish out your graph. When you think you have it, raise your hand.
That is weird. Crisscross. Crisscross, since you've got a negative here.
Yep.
That's weird.
This cross arm calculator supposed to have a little reset button in the back.
Yes.
Yeah, when I get a chance, I'll look at my book and see if I can reset it some other way. Okay, so this is one graph, if you can kind of see. It's kind of hard on the screen here, but this is the green graph. You can see that the sinusoidal axis for this graph is still the x-axis, but now the amplitude is varying. This is the other one. You might be able to see a little bit better. The green shows up a little bit better. Looks like a jumbled mess, but the whole point of this, because we have both graphs on one, but that you see that has a sinusoidal axis that's the same as the other two, just now the amplitude is varying and changing as you go. Okay, some things I want you to add to your notes.
My nose.
Okay, at the bottom of this example 1, this is just our statement that we discussed before, that adding 3 cosine theta to sine 4 theta, sine 4 theta has a smaller period, so just to, again, identify that it has different periods, because if you add 2 things that have the same period, then it just produces like a very similar sinusoid.
Great.
Yeah, it's just gonna be
process is the same, but now you're just multiplying the ordinance instead of adding. And at the bottom of that, multiplying sine 4 theta by 3 cosine theta gives sine 4 theta a different dilation. Dilation is the other way that we've said amplitude. The function seems to have a variable amplitude. 3 cosine theta, or that bigger graph, forms what we call an envelope curve. Because it kind of encases the other graph in it.
Oh, so makes a little more sense. I thought like your one was me, and I was like, how does that even make sense?
All of this?
Yeah.
For example, me.
Yeah, I was like, for example, me, but this Marla.
Gross. Decided to your worthy of being in the Chuck Norris folder. Find something like that.
Excellent. Glad I made it to Chuck Norris status.
What?
I'm taking H's class.
How'd that happen? Tell Mr. H about that. Did you know Ms. Guile stole one of his coats?
And
Yeah.
lived?
What?
And lived. He's so mad when people steal his coke, and like she comes up to me.
That's important too. Oh, I thought he said coat. I was like,
Coke.
coat.
I know,
Go
so
ahead,
did I. I
get
was like,
coat.
what
No,
the
that
heck?
I was
Coke.
good.
Like she was
No.
sitting here with it, and I was like, "Where did you get that?" And she's like, "There's a big drawer of them in the teacher room." I'm pretty sure those are Mr. H's.
That's funny. Everybody good? No?
And
Okay.
just flying through the door.
30 more seconds to write down what you need
Yeah,
to.
we were making up some narrative about how Mr. H.
Without rolling your eyes, me, Amanda Austin.
Oh, I did not roll my
What's your middle
eyes.
name?
I'm not telling you now.
I'm gonna look it up.
You have to.
Amanda Nicole Austin, what are you doing?
Did you just guess that?
No, I
She
told
said
him.
it.
How crazy would that be if like
What
your
happened to
dad
the neighbor
is
code?
kleptomaniac?
Okay,
Yeah, like
yes,
she-
you do have it written.
What's Daddy's middle name?
For this.
Mina.
Yeah,
Fred.
that one.
Mina. Oh, I've asked you that before.
Nobody knows my middle name.
Listen, Mina.
Con, David.
No.
Wait, what?
Connor, Con, Billy, Dillon.
Wait, you're not
Where
for
did
real,
that
are
come
you?
from?
No.
That's a nickname.
I'm gonna name Mike.
Con Dilly is my middle
His
like,
nickname's Con.
And why?
There's like 1,000
Okay, are we
girls in
good?
school with the middle name
Yeah.
Lee.
Isn't that like Hong
Really?
All right.
I am 30 seconds. And Lynn.
Make it 10 seconds.
Do you want me to just give you
It's
my
like
old
a-
notes?
My middle name is
Wait, you wouldn't be able to read it.
I'm Chase Allah Reynolds.
Okay, bye-bye.
What's
Okay.
that name in reference to, Miss Cross? It's a really old cartoon.
What?
Hong Kong something.
So you listen
King
to
Kong?
that. It's a really old cartoon, so we
Donkey
should
Kong.
Donkey Kong?
No, is it Hong Kong Philly?
Yeah, we like jumped out of the.
Yeah.
Oh.
Hong Kong Billy and Hong Kong Philly.
Hong Kong what?
Over the weekend, I'm just gonna listen
Hong Kong
to these videos.
Because they're random and
It's just like,
constricting.
wow, this is funny.
You know what I think show was really
So I'm just gonna start writing and hopefully you guys get the hint.
If
That's a good
anybody
point.
needs to use my old notes, I copy down what you just said.
CJ, you should be really awkward with help because usually people are tuning in and out.
Wait, what?
Amanda.
Or they're just,
This cross
ripping
type of
everyone.
cartoons through Molly Watch.
It's kind of sad that on several people's work habits, I wrote things like, try to be a little nicer.
Ouch.
Several people in this class, not just one or two.
Sorry, you can say
Was
my
it
name.
me?
I won't yell.
Was I one of them? A, B.
Connor.
I was.
I'm actually
I apologize to
Whatever.
But see, at least twice a day we always hear.
From me?
From Donnie?
Twice a day? At least.
You're like stunned.
Yes.
One day I'm going to track how many times you sigh. Or grunt, or whatever.
We're all about to get a beating.
Yeah, I'm about to go off. I actually went to a anger management class once just to see how it was. And like you say one thing wrong and these people freak out. Like it was really exactly, like, have you ever seen Anger Management? The guy comes
Oh,
out
yeah.
and like, asks them, the guys to, like, please quiet down because they're having dinner.
Yeah.
It's exactly like that.
Say what?
It was really bad.
The movie I did it.
Okay, this is probably fourth or fifth time that we've written these statements or said these statements or gone over these statements. So do you think it's important?
Maybe.
Yes.
Probably. That adding produces a function with a variable sinusoidal axis, multiplying produces a function with a variable amplitude, and your two sinusoids have to have what?
Same.
You know, something.
An
This
argument.
looks like
Halo 2
this one down
They
here.
have to have different periods. If they have the same period, it's like the last objective that we did. It doesn't affect the graph.
This one down here.
Yeah.
It's like you add it.
Mhm.
Hey, Miss Cross, look to abbreviation.
So you know
Okay.
what we could do? We could draw in the middle. You know what we could do for this sine? Or for this cosine graph? We could draw it right down the middle and just
Oh, we're going to.
call that good.
It's not good though. All right. We can use the properties of sums and products of sinusoids at different periods to decompose a complicated graph and to find the two sinusoids that formed it. This is what harmonic analysis is to take one of these sound waves that's created by two others and then like decompose it to figure out what two made the graph that we're looking at. So the first thing, and this is why we've gone over this over and over and over again so far, is that you have to determine if you are adding or multiplying, because it's going to set up the problem a little bit different. So does this have a variable sinusoidal axis or a variable amplitude? You choose A. That means, and I'm going to write down your thought process here because there's not a ton of work that we show here, but there is things that you have to pay attention to and think through. Okay, so your thought process.
Is this like the science behind a guitar harmonic?
Sure.
No.
Tries to try and
Well, yeah. Yeah, because you have, it's going to produce different waves playing at the same time. The sinusoidal axis varies. So it is a sum of sinusoids. That's usually the first thing we look for. So if you know it's the sum of sinusoids, then your next step is to do what Danny, I almost called him Danny. Sorry. I don't know why. To do what Donnie suggested and draw in a sinusoidal axis.
I go. Do it for me.
Huh?
Somebody who has some knuckles to crack.
I just cracked.
I just cracked them all, so.
Pretend that's me.
Pretend that's me.
I cracked my toes though. Listen really closely. There's one. Okay, I think that's all I got. Not a very good toe cracking day. Okay, this class is
Weird.
I was gonna say, I'm waiting for like Rosie to like look into these, going, what did I do?
I don't know. Okay.
Oh, cool.
Say what?
She's gonna say she got arrested.
So when you draw the sinusoidal axis, you just kind of eyeball where that sinusoidal axis would be for the curve that we have. Okay, so you draw it in. Alright? And then you find a particular equation for that sinusoidal axis. So that curve that I just drew in, we're going to actually come up with an equation for it. So first, is it going to be a sine or cosine?
cosine.
It's going to be a cosine. With a cosine curve, I need to have an amplitude. What's the amplitude of this?
It should be 4, but it looks like the upper and lower bounds are 5.
Because doesn't it look like this is the sinusoidal axis then for this curve?
Yeah.
And then it looks like it's at 4.
Yeah, but it
Five
says
is there?
that the
It's
upper and lower
4.
bounds are 5 and negative 5.
Those are
But
just
this
lines.
doesn't reach the upper bound. It's less than that.
Then why is it?
Because it just reaches lines.
Just had it up there.
I'm cool with it now.
There should be 3 something. Or
Like
they
That
even
upper
have
and
it-
lower
they
bound
even
does
have
not
it
necessarily
marked.
mean that it's the upper and lower bound for this.
It's not even an upper and lower bound for.
Kinda supposed to be like graphical, but
It's just maybe it's how it's marked. But if you look at where the space is between the high point and the sinusoidal axis, there is a space of 4 there. So we can say the amplitude. It's not going to be guessing. You're going to probably have whole numbers. Like, it's not going to be weird decimals or anything. Okay, so amplitude's going to be 4. The other key thing that you have to determine is the period. So, to get from high point to high point, how many units is that?
5 or 10.
10. Okay, so from high point to high point, we have a period of 10. So to write my equation,
Flip it and, wait, this is radian, right? So.
yeah.
Flip it and.
So we're going to flip this to get my b value. Multiply by 2 pi, so you get pi over 5. So we have pi over 5 x. There's no phase displacement with this. So that's going to be our equation that models that sinusoidal axis.
So maybe you can't tell the cross cell there is
None of these will have phase displacement.
and no changes. Like to the sinusoidal axis you moved up, straight up.
You could have a phase displacement though, right?
Not for these.
As long as both of them were the same phase displacement, right?
Yeah, but essentially then it doesn't matter.
So if you have a different phase displacement, you can't do any of these.
Hmm?
So if you have a phase displacement, you can't do any of these.
Well, it just gets more complicated, and we don't do the more complicated in
We
a
do
class.
that.
We wouldn't do it in calc. It would be like in an advanced trig class or something.
Ooh, advanced trig. Sounds like fun. You do identities in advanced trig?
Yeah. Okay, ladies and gentlemen, as soon as I stop talking, does it mean we need to get distracted? All right, the smaller period sinusoid is next. And we're going to find its particular equation. Okay, so we have y equals. Now, if we look at this curve now, what's the amplitude of that curve? Oh, you can't see it. What's the amplitude of this curve?
2. Whoa. 2.
2? I'd say it's about 2. If you look at the curve, the smaller sinusoid curve, the amplitude from this sinusoidal axis now to the high point would be about 2. Okay. So the amplitude is 2. Is this going to be a sine function or a cosine function, the smaller sinusoid? It's going to be a sine function. And then this is how you find the b value. You count how many cycles of the smaller is in one cycle of the larger. Okay? So we have, count with me, 1, 2, 3, 4, 5, 6, 7, 8. Now I'm halfway, so there'd be 16. So you have 16 cycles in one cycle of the other function. The b value becomes 16 pi over 5. So you use the same period, except you're fitting 16 of those in one cycle of the other.
You could divide it by 10 and make it decimal, but still be a period.
Right, but we're going to keep it like this.
Do you
Okay.
want it, would you rather?
I'd rather it be like this, because then it's going to be more exact.
16 pi over 5.
Alright, so the 16, this makes 16 cycles in one cycle of the larger.
Is that the equation for the sine function on that curve then?
Mhm.
And not the sine function that made that the other sine function that added together with the cosine function? Did we find that one?
We did find it. It's this plus this would give me that graph. So the fourth step here is to,
But do you draw the other one? Or do you just need the equation?
you just need the equations. So we're going to write the equation of the composed function. And since we know that it was a sum of sinusoids, then you take your two sinusoidal functions that you found, one representing the larger sinusoid, one representing the smaller, and you just add them together.
So you multiply.
That's your answer.
So they'll ask you to do it by saying find the equation of the.
So this,
The question will be find the particular equations from this graph. And it'll look like a graph like this, or I'll say perform harmonic analysis, which is the same thing.
So it's pretty much the same graph, you just push this down.
Uh-huh. Yep. All right. Before we do example 4, which is the other type, I want you to get with your
You seem to be here today.
let's go with your tangent partners. And I want you to do in your exploration exploration 50 and so exploration 50 I want you to do 1 and 3 together right now.
Did you see it?
Theta?
I've already been selected for one.
plus 2 cosine 28 theta.
Oh.
We got is it alright if our amplitude's a little bit off? Cause we just kinda, you have to estimate.
It was like,
We got so much period.
we got 2 1/4.
Okay, 50. When you draw on the sinusoidal axis, you do need to have an amplitude. The best way to figure that out is to look actually where it connects with the the y-axis, because that's going to be at a high point for the sinusoidal curve or that graph, and then to look between that high point and the next high point, it's going to be 2 spaces, because like it would connect like right there.
Cause we said 5 was the cosine amplitude.
For the cosine amplitude,
Yeah, like the line that you draw through it. 5 cosine 4 theta plus 2 sine 28 theta.
that one would be
Cause it looks like that point, that overlap there at the end there, it looks like it looks like that would be where the middle point would be, like where you would start drawing that.
because you'd start drawing it right there at 4 though, because that's the middle of that curve.
Is it that
It would need to be 4, yeah. Because even if the amplitude's off a little bit, you're gonna have a different curve or a different graph.
But it's just
Yeah.
estimation.
Y equals 4 cosine 4 theta plus 2 cosine 28 theta.
It's just estimation though. It depends on how you're looking
I
at
mean,
the graph.
when you're drawing your curve, that's why drawing in the sinusoidal curve very carefully is important. But if you're drawing your curve and I see that you're drawing your curve wrong, or just were a little not precise with it, and that's where you got the 5, then I'd probably let it go. But
Basically, if you don't get it perfectly right, you get an idea.
what he said. All right, for number 3. For number 3, you should have y equals 2 sine 1/4 pi x plus 3 cosine 5 pi x.
Exactly what I have.
Because there's 20 cycles. Yep. Okay, you're drawing your curve, right? The amplitude there for your sinusoidal axis would be 2, right? That's what it says. Yep, 2. It's going to be a space of 8 units from, this is actually a sine curve for your sinusoidal axis, so it's going to be 8 units. You take 8, flip it, multiply by 2 pi, so that's where the 1/4 pi comes from. And then if you count the cycles, there's 20 cycles between the y-axis and 8. And then 20 times 1/4 pi is 5 pi.
That's cosine.
And that's cosine, yeah.
And that x is.
Yep. Amplitude was 3.
Could you switch like have sine cutting cosine in front and then cosine?
I will say, because at this point students think that sometimes you always have to have like a sine and a sine, or cosine and a cosine. Like you'll notice for number 1 you had 2 cosine functions, and for number 3 you had a sine and a cosine. So they can be mixed or they can be the same function. Just depends on the graph. Alright, go ahead and go back to your original seats. We are going to finish up with example 4. Okay, so this one has a variable what? Amplitude. So the first thing that you need to identify is what's varying. So the amplitude varies here. So it is a product, yep, of sinusoids. Notice our second step is always to deal with our larger period sinusoid. That's what we're going to actually do here now. You're going going to sketch the longer period sinusoid. This is what we call the envelope curve, because it kind of envelops or closes in the graph that you already have.
Wow, I just realized that the word envelope was connected to the word envelop.
What?
Wow. Yep. I just realized that.
The envelope curve
Envelope and envelope.
is tangent.
Tomatoes, but.
They're kind of used for different things, though.
Yeah, well, like the word envelope could now have been like if something.
I'm gonna
An
just stop
envelope
talking.
A letter.
An envelope envelops a letter.
Wow.
Congratulations.
My life has meaning now.
Teachers would be proud of you.
Yeah, I stopped talking. Alright, the envelope curve is tangent to the high points and low points on the smaller cycle, which we haven't drawn any yet, but we will. And then after we sketch it, you find the particular equation.
So multiplication of sine and cosine is a tangent?
No. When I say tangent, When I say tangent, it's like in geometry when you talk about a tangent line. It's a line that connects with a circle in just one point. So when I say that the envelope curve is tangent, I'm not talking about the sine function tangent. If you say, Mr. H went off on a tangent in his lecture, it means that he was talking about something and then totally did something like some of us in here do sometimes, and stop talking about what we were talking about and then go off in a completely different direction and have to come back. So tangent just means that you touch in one spot and then it keeps going. So when we draw in our envelope curve, it's just going to touch the top of all your high points. And then your low points. So you'll see that this larger sinusoid envelops the graph that we already have. And we're going to find a particular equation for that curve. Yeah?
I don't mean to sound dumb, but why does it do that?
Is that because
Why does it what?
Is
Do what?
it, like, why does it envelop
I asked those kind of
that
questions.
envelop other one is it from the acceleration of the cosine?
I asked those kind of questions.
It's the way the y values work together to get the new graph. Yeah.
Brad, the only dumb question is a question I did not ask.
Oh, touche. Alright, so y equals. Now, first of all, is this going to be a sine or cosine?
Cosine. Oh no, sine.
It's going to be a sine. Okay, we need to figure out an amplitude. Do I see an amplitude?
I think you do.
I think I do. What is that?
5.
Should be 5. The amplitude is 5. I have a sine function, and then we have to figure out what the period is in order to get my b value. So, what is the period of this function?
360.
Just 360,
Yeah.
right? So if the period's 360, you take 1 over 360, multiply by 360, and you get,
Top.
So, 5 sine.
X.
and actually we have theta, right? Okay. Yeah. Alright, so you have y equals 5 sine theta for your first one. Now, the second smaller sinusoid, the one that's kind of jammed in with the curve, that's the next one we're going to look at. We always let the amplitude of the smaller period sinusoid be 1. Because there's no way for us to be able to tell what the amplitude was. And actually, the envelope curve that we have makes it okay that we don't need to know what the original amplitude maybe was of the smaller period sinusoid. So we're going to let the amplitude of the smaller period sinusoid be 1 always. You're going to count cycles. Now, when you count cycles in an envelope curve, really what we're doing is we're counting the tangent points, how many times it connects. So when you count cycles, you're looking for points where the given curve is tangent to the envelope curve. Okay, so here we go. Now some of them are going to be a little hard to see because they're so small, but there is a little hill here, is there not?
Yeah.
Okay, so we have 1, and I usually circle them. 1, 2, 3, 4, 5, 6. There's not one there. There's not one there. 7, 8, 9, 10, 11, and there's a little dip right there, isn't there?
Yep.
So there is 12. You count, yeah.
So we're not counting either one in the middle.
You don't count either one because if you look at this, it kind of goes right through and it doesn't touch the lower or the upper bound in that little section there.
But last year we kind of like argued that when it goes through the one at the beginning, it's actually like going through the line, and this would really be a tangent. So
It follows. No, I don't remember having that argument. I think argument last year was around this piece here. Some people thought it touched, but it doesn't.
Crossover rule.
It does touch here. It does touch here. Okay, so we have. Oh, and then you find the particular equation. Do we have a sine or a cosine function there? It's going to be a for the smaller sinusoid in there.
The smaller is
We have a sine, right? So you have y equals, remember the amplitude is going to be 1. So it's going to be sine. And then because 12 was the number that fit in, it's just going to be 12 times whatever the original period was, which was, in this case, 1. So it's going to be 12 theta. And then your composed function. Would be y equals 5 sine theta times sine 12 theta. And that's what your answer would be right now. Okay. In the last few moments, I'd like you to get back with, or just maybe work with somebody around you and do number 2 on exploration 50. So you get one practice of this before you leave.